As you've seen, anonymous types prove to be powerful when used together with a link, and when you want to present this data in the UI through data binding. While the anonymous type's properties are read-only, there is a way to create a new instance with copies of all the properties available into another instance. Then you can specify which properties you'd like to contain different values. Doing so is known as a non-destructive mutation. You're not mutating the original instance because you can't. It's read-only. Instead, we're going to introduce a new concept and a new keyword. With an instance of an anonymous type, you can declare that you want a copy of this with one or more properties changed. This is known as the with expression. It was originally introduced together with record types, which are covered later in this course. Using the with expression does not allow you to add or remove properties. It's simply a way to create a new instance of the same anonymous type with some different values. For example, let's say that you want to change one of the order summaries and apply a 25% tax on the price. Because it's read-only, you have to construct a new instance. We can take the first order summary and create a copy of this instance using the with expression. Inside this statement, you can specify the properties that you want to change. Since this is a generated type, and we're using it in the same method where it was generated, the compiler knows exactly which properties are available, and therefore the IntelliSense will show us all the available properties that we can modify. Now we can state that we want to change the total price of this order summary to apply a 25% tax on this single instance. We now have a new instance of this order summary. You could dereference what the first element in the array points to, and have it pointing to this new element instead. The benefit of creating a new instance instead of allowing to modify the original instance is that in multi-threaded environments and applications, mutating objects can cause problems. The IEnumerable doesn't allow you to replace an element, so you'd have to either retrieve this as a list or as an array to do so. It's worth to keep in mind that just like with any normal type, if you have a property that is a reference type, that simply points to the instance. And that is true for anonymous types as well. We can experiment with this by adding the line items to the anonymous type. What do you think happens when the anonymous type is copied using the with expression? For the property line items, it only copies the reference. This means it does not make a copy of the entire array. For strings and value types, there will be a copy, but for reference types, that's not the case. What does that mean? Add some code that retrieves the first line item from the first order summary. Then modify its name. Since the line item is a simple reference type that exposes a public property with a getter and a setter, we are allowed to do this. Before we run this, take a moment to think about what's going to happen. Will the order summary with the discount have a different name for the line item? Let's run this to find out. As you can see, the name was changed for both of the instances. This is because the enumerable for line items is a simple reference to a collection in memory. Both instances of the anonymous type will point to the same collection. This is something that you should definitely keep in mind. You've seen how powerful anonymous types can be, and it will reduce the amount of unnecessary code in your applications. The only thing that we haven't looked at is how to return an anonymous type from a method, or how to pass it as a parameter. As mentioned many times now throughout this module, that is not the intent of anonymous types. However, that doesn't mean it's not possible. The anonymous type that is generated is a normal class. As other reference types, it ultimately inherits from object. A method that has the return type object, a method that accepts an object, or a property that is of type object could point to an anonymous type. You can change the method signature of the method process to return an object, then return the instance of the anonymous type. If we then go back to the program, we can capture what is returned from this method, and we now have a local variable of type object, which is the instance of the anonymous type. This will make it difficult to work with. IntelliSense wouldn't be able to pick up which properties are available, and you'd have to introduce code that looks up properties and gets their values in runtime. You can do this with something called reflection. Doing so will impact performance, as well as making the code harder to read and maintain. To get all the properties on the anonymous type, you can first retrieve the type information. This will contain all the necessary information about the class. You can then get a list of all the properties, and with the property information, you can then get the value from the instance that contains this property. Hopefully, this is convincing enough that working with anonymous types outside of the current method is a bad idea. Don't use them as return types or pass them as parameters. That is not what they are intended for.